started. So today is at least your first day of reckoning of about 6 more that you'll have throughout the class. So Scratch projects are due today. I've spoken with a lot of you yesterday during discussion sections, looking at some of your projects, giving you feedback. Some people have been coming to office hours. So hopefully those are kind of coming together now. I will be holding office hours again today, so my office hours are Monday and Wednesday, but it was 4 to 5. I actually extended it now, so it's going to be from 3 to 5 now, because some people had conflicts, so hopefully that 2-hour block is enough of a time window where you can be able to come to office hours. If there's still a conflict, you somehow have too many classes jumbled together, send me an email. We can always try to work out another appointment if you really need help. So, one of the things that I didn't mention on Monday is that we're going to now start to introduce readings from the textbook. So I did post the readings technically on the website, but I didn't ask you guys to check, so I wouldn't have expected you to. But we're going to start sort of slowly working out of the first book in the syllabus, which is Think Java, How to Think Like a Computer Scientist. It's a good book. It's a bit of a short book, and so it's painless. It'll kind of help us as we're really getting through it. It won't be very in-depth, but it'll help us introduce a lot of the concepts that we're slowly starting to go through right now. So I assigned chapters 1 and 2 as reading on Monday. It's not very big. It's only about 20 pages. You'll probably go through it in maybe half an hour, so it's not too bad. And then today, we're going to, if we have time, probably get to this up in chapter 3. And that's also a short chapter, 10 or 15 pages. Not too bad. And so we'll start sort of using that as a bit of a guide in addition to some of the other things that we do in class. So to sort of give you something if you are, so in addition to watching the lectures, coming to office hours and asking questions, this is sort of another resource using these textbooks so that you can have an additional place for reference. So yesterday, actually before I get started, I want to mention one quick announcement. So on the subreddit, someone had a good idea that I figured we would start doing now. So I posted these lecture discussion threads. So if you do have your computer and you are following along, it's a way for you to communicate with others. If you have it open and someone asks a question, other students can respond. I might try to open this with maybe 5 minutes left of class and see if there are any pressing questions, and I can go back. And so if you are intimidated, you don't feel like stopping me, messing up my flow, or you're too afraid to ask a question, ask it here, and then I'll go and take a look at it and either respond offline sometime after class, or if I get the chance to, I'll actually respond in class. And so we can kind of have more of an interactive feel to it, because I do show up every day and I sort of talk at you, but you guys are really here to learn just as much as I'm here to teach, and so I really do appreciate when people are asking questions. If you're getting stuck, if you can't read something that I'm typing, raise your hand, make me aware of it, post it on here. Let's keep it interactive. So, the next thing that I want to kind of cover, after I sort of made you all go through the pain of adding manually your Java path to your terminal, I'm going to show you today a way to do that sort of nice and automatically so that you don't have to do that every single time. I wanted you to sort of get used to typing the statement again and again so you sort of understood what's going on. But now we'll start to show how computers can be used to automate certain processes. So if you do have your computer up, you can follow along. I'll probably post a little handout or something on the internet showing you basically the steps that I'm about to go through. It's not too bad, but the basic idea is that your terminal, your bash terminal as it's called, has a script that it runs every single time you open the terminal. And if you put commands in that script, it'll have things that will run every single time you open. So for example, a command such as using this export statement that added the Java path, if you put that in this script file, it'll automatically add it every time you open that file. So where is that file? I'm on a Windows computer, so I'm using Cygwin, but this will be in your home directory. So if you're using Cygwin, it'll be in home / whatever your name is. That's your home directory. If you are on a Mac, it's usually in users / your name. So I'm going to navigate now to the Cygwin directory, which I've installed on my C drive, the home directory, and then my data link ID, which is that. So you can see this is empty. I just installed this today. One of the things that I don't like about these computers is I have to reinstall the software every single time before class, which is why if you're in here early, I'm always kind of typing things out and working hard about 10 minutes prior. So you can see there's a list of files here, and there's a dot before them. So in Linux, a dot before the file name or a period means ignore this in the command line. So if we actually opened up the command line, and let's make this a little bit bigger. So if we open up the command line, I'm in my home directory, but if I type ls, there's nothing in there. So there is a way to view hidden files, and I actually forget which one that is. And if I forget, I can always go to the man pages, which I've now taught you guys how to utilize. If you want to find a hidden file, it is... Does anyone know off the top of their head? It's A, that's what it is, right. So if you do ls and then an option, so we haven't gotten to options yet, so don't worry about this if this is all looking a little foreign to you, but you can sort of utilize an option in your command by typing a dash and then something else. So this is an option, which is me saying, I want you to actually show the hidden file. So if I type ls and then dash A, now it'll show me the things that exist in this folder, which is .-profile, .-rc, .input, etc. So the file that we actually want is .-rc. This is the script that will run every single time you open up your command line terminal. So I'm going to go ahead and open something. Well, I'll go ahead and open it here. So I'm in Sublime. I'm going to go and navigate to the same spot and open up that .-rc file. And what you'll see might look a little cryptic. So what you see in front of these words here are hashtags or octothorpes or whatever you want to call them. In a bash script, these mean comments. And we won't be doing very much bash scripting, so I don't want you to worry too much about memorizing the syntax or worrying about it. And comments in bash scripting is not the same as comments in Java, but just suffice to say you'll see a lot of stuff in here that the script is basically ignoring. And what you want to do, so you can see there's something that's sort of colored here, and it's doing something. Don't mind as much what that means. It looks incredibly cryptic. Bash scripting is a lot worse than Java scripting, but what you want to be able to do is go all the way to the bottom and add something to the end of this. So if I add my export statement here, then every time I open up this terminal, it will go ahead and run that script and do the exporting. So let's confirm that this is doing what we want it to do. So do I have JavaC on here right now? And you can always just type JavaC to see if your terminal is recognizing it. And if it says command not found, it's not recognizing it. So since I'm not sure where it is on this computer, I'm going to confirm that Java is in the place that I think it is, which is in Program Files, Java, JDK. And you can already see most of you have the .45. It's already been updated since. You don't have to worry about updating every single version number. If you have 45, it'll work just as splendidly as if you have 51, which I just downloaded today. But because this is 51, I can't type the export with 45. So keep that in mind that you might have 45 installed. So always go and check which version of Java you actually do have. And so because I have this JDK, I'll go ahead and type it here. And you'll have to make sure that you do this in excruciating detail the first time because you can't use autocomplete in a text editor the same way that you can on the command line. So I want path is going to be equal to $path, colon, and then I start actually typing the path, which in this case is sig drive, C, program. And so I kind of wrote this out without explaining it, but now I'll actually start to explain it. You can't use spaces in the command line because it actually sort of segments the things that you're doing by spaces. So if you do a command and then a space and then an option, it can interpret that, okay, there's a space here, so what's to the left is a command, what's to the right is an option. And so you can't have spaces in, say, your file name because it thinks that you're basically giving it an additional piece of information. So the way that you can introduce a space is known as an escape character. So we use the backslash to sort of say, okay, so it's reading sort of from left to right. Once it hits the backslash, it knows, okay, anything after this, do something special. And there are a couple of different escape characters that we'll get to maybe in a couple days. But suffice to say, if I type a space now after this escape character, it goes ahead and interprets the space as if it's part of the file. Whereas if I just had the space on its own, it would say, okay, your file must only be this first part, and now you're giving me a new piece of information. So you can even see, using Sublime, it went and turned purple, and so that's sort of Sublime's version of an escape character. And so you can sort of easily pick out what these are. So I have program files, and I'm going to bring this down here so I can see it as I'm typing. So /, not backslash, because if I'm using backslash, it's going to interpret that as an escape character. / Java, then JDK, 1.7.0 underscore 51, and then once you're in the Java folder, you always have to add this extra little bin, which is where the JavaC actually lives. So I have this whole command. Let's see if I save this, if it actually works. So now, if I go over to JavaC, it will not work. And the reason it will not work is because you actually have to restart the script for it to run bash RC. I haven't done anything to make the script actually run. So if I close this, and then I'll reopen it, let's see if it works now. Now it works like a dream. And so now I don't have to do anything. I don't have to ever add the path ever again because it's in bash RC, and so it'll just run every single time. And as you sort of get familiar with the command line, and maybe later in the semester I'll show you ways that you can sort of change the command line, change how certain things are act. You can set sort of all of these parameters for how you like to use the command line. You can set colors for things that maybe files show up as different colors than folders do, or maybe add shortcuts where I type this command and it immediately goes somewhere else. You can sort of add all these things, and you'd add those into your bash RC. But suffice to say, if you do this once now, you should be fine after this. So, on, what's today? Wednesday. So on Monday, we were talking about variables, and I showed you that there are, in fact, different types of variables. And so we kind of covered sort of the long list in the fact that you won't really be using much of bytes or shorts, but really ints. So if you want to represent an integer, that's an int, and that's, you have to declare this type when you're using Java, so it knows that all the operations that you use, or that you do with it, are an int. If you want, so an int is 32 bits, which can only count up to about 2 to the 32. So if you have a string of 32 ones and zeros, the highest that number can represent is about 4 billion. So if you want to go higher than that, you have to use a long. You probably won't need to worry about that too much in this class, so I wouldn't worry about committing ints and longs and all this to memory, but suffice to say, it's there if you need it. If you want to represent a decimal point in computers, we call that a floating point number, for reasons as to how that's represented in binary. A general floating point number is also only 32-bit, but you can go sort of one step higher and go 64-bit, and that's a double. And so, for reasons of really tradition, we use ints when we're talking about integers and not longs, because we really don't need really long integers. But generally, when we want to use decimals, we do kind of want that added precision, so we'll be using doubles, which are 64 bits. And then you also have booleans, but you won't really be using the boolean data type very often, but it's good to know that that is a type, because things like the if statements, which we haven't really gotten to much in Java, the if statements have sort of a parenthesis, and you can only put Boolean expressions inside those parentheses. So it's good to understand sort of what's going to give you back a Boolean type. And then the char, or the char, or however you want to pronounce it, is a letter, or a symbol, or a punctuation mark. This is how we sort of represent actual ASCII characters in Java, by creating a type char. Does anybody notice a type that's not on here that we've been using? A string. So why wouldn't a string be on here? That's certainly a type. So there's sort of a difference between what we call primitive types, which are types that are actually hard-coded into Java, and then object types, or class types. And so these, we haven't gotten to objects yet, but this is sort of, the string is actually not sort of a primitive indivisible unit. It's not sort of an atom. It's more of a molecule. It's actually an array, another term we haven't really gotten to yet, an array of characters. And so you can do operations on the string, but what it's actually doing at sort of the most basic level is it's operating on characters. And so the string, I'm introducing it early because it's a lot easier than if we're operating strictly on character arrays. And in C, there is no string class. So if you learn a thing like language like C, a lot of the syntax is actually very similar to C and Java. One of the nice things about Java, though, is that it has the string class, so you don't have to deal strictly at the character level. But it's something that is good to introduce so you sort of understand what's going on. And so I talked about the different bits that each one has, and a char is only 16 bits. So 2 to the 16, that's basically the number of possible characters that it can hold in the system. And so the ones in bold are pretty much the only ones that you're going to wind up using. So I'm going to work today primarily out of the command terminal and do some things in my Cygwin and my Sublime. So, let's go ahead and create our basic skeleton. So, on Monday we called it Calc. Today let's call it Calc 2. So I'm going to create a public class, and its new class is going to be Calc 2. Or actually, maybe I want to call this the lecture number so that we don't get confused. No, I'll call it Calc 2 because I'll probably be changing different names. So I've got my public class. and then I'm going to create my main statement. And if you guys have already been writing your Hello World programs, you should be familiar with at least not as much what these mean, but typing this basic sequence over and over and over again, where you create your class, and then sort of the curly braces defining where the class, what's inside the class. Then you define your main method, and then you create your curly braces, which define what's inside the main method. And so I'm going to go ahead and save this. So I want to make sure this is in my home directory, which it is. So calc2. So if you haven't already gone ahead and edited -rc, but you're sort of either doing this later at home or you're doing this here, try to navigate to your Cygwin home directory. And if you followed the lab yesterday, which actually, since some people haven't been getting emails from me, I want to go ahead and make explicit. On the class website, I have actually posted a worksheet. So if you didn't go to lab yesterday, make sure that you check the website, and there is a lab to sort of fill out. It's optional if you haven't gotten Java up and running yet, but it's something to sort of walk you through the process of installing everything. So if you did do that, you've already sort of created the basics of a file structure in your Cygwin system. We created labs, and then so we created a COP3502 folder, and then labs inside that, and then you sort of created the lab 0, which is what that lab was. So you can use your own organization. I would advise maybe inside COP3502 you create a lectures folder, and then maybe number it by lecture, and you can sort of store all the code through each lecture. But since I have to reinstall Cygwin on this machine every time, it's not going to save that state, so I'm not going to use that same structure, but feel free to organize yourself how you want. So I'm just going to save this at my home folder. Is there a question? I thought I saw somebody's hand start to be raised. So I'm going to save this as calc2.java. Remember, I always have to save the file as the same name as the class. And when we get to objects, it'll become a lot more apparent why we have to do this. So once I save it, I get my nice little syntax highlighting. So now I want to go ahead and actually show off some of these types that we've been learning. So I did some basic stuff. I did a basic calculation on Monday where I declared two ints and I sort of printed their sum. I don't know what I want to print yet. Let's see. So let's go ahead and define an int x, and let's call it 5. And then let's define another int y, and we'll call that 20. And so I can define another variable, maybe of type int, and call it sum, and store x plus y. And notice how I'm using a semicolon at the end of every statement to sort of demarcate that this is the end of my statement. And so I can go ahead and say something like your sum, and I have to use quotes, your sum is whatever the sum is. And so remember, what I'm doing here really is I'm taking a string, which is this little part of the phrase, your sum is, and I'm taking a sum, which is actually an integer, and I know it's an integer because I've declared it as such, and by using the plus operator, if your inputs to your sort of plus operator, your left side and your right side are considered sort of the inputs of the thing that's adding together, if one of those is a string and another is a number, it will always sort of automatically convert the number into a string. If both things on both sides of the plus are numbers, then it treats it as if it's a number and it does the actual calculation. So this is a concatenation operation because of the fact that this is a string. And so if I go ahead and quickly save this as I save it, I type javac calc2 and try to compile it. No errors, good job. And then I run java calc2, and it doesn't do anything. Why doesn't it do anything? Can anybody guess? I actually have no idea. I'm trying to look at the program and figure that out myself. Well, let's see. We do have a class file in here. Yes, we have calc2.class. The main function's correct. Let's try not using the sum. And so
I'm getting an error. Like this class name is calc2 and class name is classes.
I think I made a boo-boo. So I don't think you can save numbers in a class file. I've personally never needed to, and so this is sort of the first time I've tried to. Let's see if I just save it as calc, if that works. Yours works fine? I should be. Yeah. So no matter how experienced you are, sometimes you still get the very basic of errors. So let's try compiling calc.java, and as you're saying, this probably shouldn't make a difference at all because of the fact that it's running equally well on others. Whoops, can't include the Java there. Okay, that worked. So it might be something with the configuration where sometimes it doesn't accept numbers and sometimes it does. So I would say, to be safe, don't include numbers in your class file. So I'm going to call this calc, and I'm going to spell it out explicitly so that it's different from the calc that we did before. Calc2. And I'm going to save it as calc2. Nope, not as calc.java, as calc2. So I'm using a common form of sort of writing out multiple words together without a space that we call camel case. And you'll get used to this when you're writing variables in which you want to sort of cram multiple words together. You can't use a space in a variable name. So camel case sort of starts with the lowercase of the first word, and every time you reach a new word, you just use an uppercase letter. So it kind of squeezes everything together. So calc2.java, and then I'm back to where I was before. Okay, so I wanted to do something simple, and this took a bit of a detour, but so you can easily add two numbers together. So what happens if one of these, for example, is a double? And actually, let's go ahead and remove this other variable here, because I don't want to explicitly declare it as an integer. I want to actually do the operation inside this print line argument. So what I'm actually doing is inside the print line parentheses, I'm giving it an argument of what I want it to print. And I'm sort of doing an operation right here by wanting to add x and y together. And actually, so there's a whole range of different mathematical operations you can do, including subtraction, multiplication, and division. So let's see what happens if I try to do division. Let me go ahead and compile it, and I'm not compiling the right thing because this is calc2. Here we go. Java calc2, and I get 0.25, which is correct. There is one thing to keep in mind, though. So first and foremost, this is all well and good. What if instead of this being a double, this was an int? And I still wanted to divide the two together. If I go ahead and compile that, I get your sum is 0. Why is that? Does anybody have an idea or a guess as to why it would be 0? Exactly. So what's happening right here, this sort of x divided by y, it sees, okay, x is an int, which is 5, y is an int, which is 20, and when you take an int and you divide it by an int, it assumes the answer that you want back is also an int. So whatever number it gets back, it automatically rounds down to the int that is that's the non-decimal portion. It basically throws away the decimal portion. And so what you actually have here is 0.25, and it says, oh, you probably just want an int, so it throws away the 0.25 portion. So keep in mind that if you want to do something like division, you need to actually explicitly declare that these are, in fact, ints, or, well, instead of actually declaring them as variables, period, if I just did this and hard-coded the numbers in there, would I get the same thing? And I do, because it sees just 5 by itself. It sort of assumes in the system that that's an int. So how do I tell Java, no, I actually want this to be a double or something else? You have to be explicit and include the decimal point. So 5.0 is not the same thing as just 5. You have to sort of explicitly say, by adding in this decimal point, now this is actually a double, and if I go ahead and compile it and run it, then I get 0.25 like I should. But there is one thing to consider in the way that computers store numbers. So what if, for example, I wanted to do 1, and I'll make this a double, divided by 3. Well, what is 1 divided by 3? It's 0.3333333 up until infinity. But can computers recognize an infinite number of numbers? No, they can only recognize sort of as much as they can store. So you have this problem now in computers where if you want it, so how many real numbers are there? There's an infinite number of real numbers. So a computer cannot possibly recognize all of the numbers in the universe. And so it has sort of a precision where once you reach a certain point, it starts to become a little bit inaccurate. So I am going to do something. And I don't want to bother with your sum anymore. I'll just print out an actual result. So I'm going to wave my hand. You don't have to worry too much about what I'm doing here, but I want to be able to print out to a certain number of decimal places, a number. And I can do that using this function called string.format. So I'm basically accessing a function that's inside this string class, and this is terminology that will become more familiar with you in time. This string function takes two arguments. It takes first the actual thing that I want to print, which in this case I'll say is 1 divided by 3. But then it also takes, as its first argument, a way of sort of formatting how many decimal places I want. And I won't generally ask you to be using this function. I just want to sort of show this by example. And so the syntax for that is a decimal place to say this is the number of decimal places I want, and then the actual number that I do want. So let's say I want 20 decimal places. And I have to tell it that I'm dealing with a floating point number. So you have to sort of include this archaic 0.20f. And so I'm printing this thing, and this thing is just saying compute 1 divided by 3 and give me 20 decimal places. And so if I save this, compile it, and I get an error, I get an error because I forgot my semicolon. Compiles fine, and let's see what that result is. The result is not what I wanted it to be. I think that's a type thing. Okay, so that is right. This should be right. I think I'm missing I have an extra or not enough parentheses. It's not doing what I want it to do. So let's go ahead and try to... I think you can only take a variable, so let me define an actual variable with my 1 divided by 3. And this is what happens when you spend a little too much time in lab sessions and thinking about scratch projects and not about the lecture that you should be teaching. Okay, let's... Semicolon. I always forget it. You will too, over time. Compile it. No. Sorry? They should be. So actually, you know, this is good. This is a chance to sort of show you that you will run into times where you are not entirely sure of the syntax. And I do a lot of my programming in other languages, so I have to sort of remember the Java syntax off the top of my head, and a lot of times I can't. So whenever you are in doubt, Google is your best friend. And so if I do string.format, I can see exactly what the string.format should be. So I forgot the percent sign. Thank you. And that's what I was going to wind up looking for. And this is sort of archaic syntax. I never use this function. You have to use the percent sign. So this is sort of a way of you telling it, I don't want you to print this string 0.20f. The percent sign acts as an escape character in a similar way where it's saying, okay, no, I actually want you to sort of do this thing. So I compile it, and now I get what I wanted to originally get. So there's something interesting here that I wanted to point out. At some point, the precision sort of drops off. So 1 divided by 3 should actually be 0.33333 up until, infinity, but it doesn't. The computer can only store so much. And what if I took this even further and went to, say, 40 decimal places? Then it continues on. What if I had, say, 1 divided by 10? Actually, let's do something better. Let's make it 100.6 minus 99.75. I'm doing some sort of random arithmetic here. And we'll do this to 40 decimal places again. So what would you expect that I get? 0.85. But this doesn't look right at all. So it's actually not 0.85. It's sort of 0.84999, some other jumbled dots. So this is sort of one thing to keep in mind, that the precision won't necessarily always be exactly what you think it is. And so if you were expecting a certain number, let's say you're doing this operation up here, and you have an if statement, and you want to say if x is equal to 0.85, do this. x may not ever actually be equal to 0.85. And so this occasionally will lead to trouble, and so precision is sort of one thing to always keep in mind. And I actually have an interesting video that sort of shows a real-life example of what happens when you don't think about precision as a computer programmer. And this is about 8 minutes long, so give us a nice little reprieve from programming. It's not a spaceship, it is a rocket. Yeah, and then the Patriot missiles as well.
Computers. We've all come to accept the often frustrating problems that go with them. Bugs, viruses, and software glitches. For small prices to pay for the convenience. But in high-tech and high-speed military and space program applications, the smallest problem can be magnified into disaster. On June 4th, 1996, scientists prepared to launch an unmanned Ariane 5 rocket. It was carrying scientific satellites designed to establish precisely how the Earth's magnetic field interacts with solar winds. The rocket was built for the European Space Agency and lifted off from its facility on the coast of French Guiana.
At about 37 seconds into the flight, they first noticed something was going wrong, that the nozzles were swiveling in a way they really shouldn't. Around 40 seconds into the flight, clearly the vehicle was in trouble, and that's when they made the decision to destroy it. The range safety officer, with tremendous guts, pressed the button, blew up the rocket before it could become a hazard to public safety.
This was the maiden voyage of the Ariane 5, and its destruction took place because of a flaw embedded in the rocket's software.
The problem on the Ariane was that there was a number that required 64 bits to express, and they wanted to convert it to a 16-bit number. They assumed that the number was never going to be very big, that most of those digits in the 64-bit number were zeros. They were wrong.
The inability of one software program to accept the kind of number generated by another was at the root of the failure. Software development had become a very costly part of new technology. The Ariane 4 rocket had been very successful, so much of the software created for it was also used in the Ariane 5.
The basic problem was that the Ariane 5 was faster, accelerated faster, and the software hadn't accounted for that.
The destruction of the rocket was a huge financial disaster, all due to a minute software error. But this wasn't the first time data conversion.
So I'm going to start this a little early. I had intended to show the entire video, and I'll post the video on the website. But there's also, the next sort of 6 minutes show also the Patriot missiles that were used in the Gulf War. They had a problem with their clock where if you let it run and run, the way that it computed time was just a little bit too quick due to a similar sort of number conversion problem with using an imprecise type. And so as you left these Patriot missiles on longer and longer, the time didn't match up with sort of the real lifetime, and the missiles fired rockets incorrectly. And unfortunately, wound up killing a fair number of people back in the early 90s. And so it's sort of a sobering example of things that can happen, things that can go wrong if we don't consider precision, and we are not paying attention to how specifically numbers are stored in our Java system, in our computer system. Okay, so I'm going to move on a little bit now. So this is precision. Now we're going to introduce our first actual package. So I've been doing some simple things with numbers. I did addition, I did multiplication. Well, I didn't do multiplication. I did subtraction. I did division. And so that's sort of primitively the extent of what you can do in Java. But there are packages that you can do many more things. So if you want to do additional operations, there is a package in Java called math. And you can invoke that package in the same way that I'm invoking this system.out package. So this is a package which contains functions, and one such function is printLn, or println. And so, in a similar way, I can invoke the math package with a capital M-A-T-H, and then call something. So let's say I want to raise something to another power. I can call math.pow, which is a function that exists in this math package that I can call and have it calculate something for me. And so a function can take arguments. It can take parameters which tell it how to operate. This POW function takes two arguments. It takes what the base is and then what the exponent is. So let's say that I want to raise 2 to the 5th power. So I do 2 comma 5 for the 2 different arguments. And then I'll get rid of this thing, and I just want to print x, so we can see what the result is. If we compile it, and then run it, we get 32, which is what we would expect. 2 to the 5th power is, in fact, 32. And actually, let's use this to calculate. So we said we were trying to figure out how many numbers an int, how high it could count by saying it was 2 to the 32. So if we do 2 to the 32, we can see what that exact number is, and treat this sort of like a calculator. And this is doing scientific notation, so you can see there's sort of an E9 there. So this is about 4.2 billion that it can, it's sort of the highest that it can count. So your next question might be, okay, this is math.pow, but how do I actually know what's in the math function? If I want to actually go and look at other functions on my own to figure out, I want to do something with numbers, I'm not quite sure what to do, you use the Java documentation. And your most helpful friend in this case will be either Google, or if you want to actually search for it yourself, the Java documentation. And I'll also post a link to this on the website, but there is online a listing of all of the classes that do exist in Java. And teaching you the syntax is sort of these first maybe 2 or 3 weeks. The rest of the course will really be, now that we know how to do things in Java, let's figure out what we actually can do by figuring out what libraries exist. And so how can we invoke these libraries? How can we use what other people have already written for us to do really cool things so we don't have to write everything from scratch every time? Imagine if you had to actually write, let's say something more complex like taking the sign of something. There is a math.sign function. There's an algorithm for given a number how to compute its sign. If you had to then rewrite that algorithm from scratch every single time you wanted to do any kind of trigonometry, that would be a real headache. So this math package actually exists in something called java.lang, not java.math, and I'll explain later why that exists. But there is a java.lang up here, and so inside java.lang there are a whole bunch of other packages. We want the math class. So you can also just Google java.lang.math, and you'll probably get right to this page. If you Google the math class in Java, you'll probably also get to, or in Google, you'll also get to this page. But this documentation tells you all of the classes that you sort of have access to. So there's ABS. Let me see if I can make this a little bigger. There's ABS for taking the absolute values of things, and notice how there's a different ABS for every type. So if you feed it a double, if you feed it a float, if you feed it an integer, it sort of knows what to do with all of these numbers, and it has a different function for each different argument. And that's something we'll see when we get into a little more detail with functions, that you have to specify in extreme detail what the type of the argument is that it's accepting. So we can do things like absolute values, we can take tangents, we can take the logs of things, you can do max and min, so you can give it 2 different arguments, 2 numbers, and it'll feed back to you what the maximum of those 2 is. So the POW that I use is right here. So if you're never not sure how to use a specific function, Google it, and this will tell me exactly what it does. It returns the value of the first argument raised to the power of the second argument. So whenever you want to do math, you want to invoke this java.math class, or this math. Whatever your function is class, and you can see sort of all the various things that you can do here. So there's also a math.sqrt if I want to say take the square root of a number like 4. I can take the sign of something. It's not actually math.sign. They abbreviate a lot of their notation to 3 letters if they could, so it's math.sin. So in addition to functions, this math class also has variables associated with it. When we get to objects, we're going to see that, in fact, every object has 2 descriptions. It has things that it can do, which are its functions, and things that describe it, its properties, which are its variables. So all of the functions are things the math object can do. In addition, there are, and I'll write this here for now, there are variables such as math.pi, which is the pi variable. And so you can actually print out the pi variable. And so I'm going to use something that I haven't used yet, which are comments, because I want to leave this sort of here and come back to it. If you type // in Java, you can see it sort of grays out. This is a comment. And so when you write Java code later on, so some of you have been writing comments in your Scratch code. It's not necessary. If you haven't, don't worry about it. But using comments is a good way to sort of document your code. And if you put it, say, in front of a function that you write, you can say, this is what the function does. Or if you want to remind yourself sort of the step-by-step operations of what each line is doing, you can add comments. So I'm just adding a comment right now so that it doesn't read sort of what's here. And whenever the interpreter is converting your bytecode into actual machine code, it sort of skips over whatever's in the comments. So right now, I just want to print out math.pi to show you that you can actually use this to access the pi variable. What did I forget? Oh, that's right. So I don't think I think it's just one capital and then, no, it should be right. Oh, because I haven't actually, so I declared it, but I haven't actually done anything with it. I don't want to actually even have that here. So I just want to print out the actual value. So let me actually say what I did here. This was nonsense, because when you do anything with a variable, you can really only either declare it. So if I declare it, I'm sort of grabbing it and saying something like int x. This is me declaring the variable and telling memory to store something of type int in its memory. I can also take a variable and I can assign it to something. Here I didn't really do anything. I just typed math.pi and put a semicolon. That doesn't actually mean anything in Java, and that's why it kept spitting errors out at me. And because that variable already exists, I don't have to declare it. I don't have to set it to anything. It sort of exists in this nice little math object. And so I can go ahead and print it out. And to a certain level of precision, that's the value of pi. And so you can nest functions as well. So I can say something like math.sign, and then enclose within math.sign, math.pi. And so what's the sign of pi? Does anybody remember from calculus? Should be 0. Let's see if it is. Very, very, very close. And so again, precision problems in computer programming. So it's very, very close to 0. It's e to the negative 16, but not quite 0. If you do any kind of mathematical operation, it'll treat this as effectively 0. But if you have, say, an if statement where you say if the sign of pi is 0, do this, it won't ever actually run. But so, important concepts. You can nest functions within functions. So I have a variable in here, and let me actually write this out explicitly using my pen. So this thing right here is a variable. This thing right here is a function. And then this part out here is yet another function. So I have a function with its arguments enclosed in parentheses. I'm sticking inside that function another function, which I'm saying compute the sign of something. And then within that function, I'm actually feeding it the variable of what to compute the sign of. And so it computes the function. So it evaluates the math variable. It passes it to the sign function, which evaluates, which then it passes it to the println function. So you can sort of nest functions in this manner. Let me erase all of that. Okay. So, this is all well and good, but what happens if we want to, say, create our own functions? And so I'll give you sort of a taste today of actually creating your own functions. And I had actually commented that out. I don't need it anymore. So we've been working this entire time inside of this main function. And so I said that every time you compile your Java code, when you go to run it, it goes and actually tries to figure out where main is, and it runs whatever's inside main. But just like we had functions in Scratch, we can add new functionality into Java. If every single thing that you programmed had to be inside that main block, things would get confusing very quickly, and your programs would be just monstrous inside. The number of lines would be huge. And so what you can do is you can sort of encode functionality, store it elsewhere, and then access it in the same way that you would access a function. Imagine if I had to write out the algorithm for math.sign every single time. That would be extremely tedious. So I can just call the function math.sign whenever I want to run it. And so likewise, I can also write new functions. So now we're going to see our first case of actually writing a new function. So if you notice, I'm keeping this inside of this class variable. So I have the left curly brace, which signifies the beginning of the class, and this right curly brace, which signifies the end. And you can't have, you can have multiple classes in one file. We'll get to that in time. But for now, everything should be within the class. So this new function that I'm going to write is still within this first set of curly braces. But now I'm actually going outside of main. So main sort of has its own little block of things that it's going to run. And so let's go ahead and do something like this. Let's create a new function, and I'm going to type a couple modifiers. that I'll explain later. So instead of writing main now, I'm going to call this new line. So this is an example that is in the book. I think it's in chapter 3 of How to Think Like a Computer Scientist, where they define a new function and they call it new line. And so what are the things that a function has to have? Well, it has to have, it has optional modifiers. For now, just include it. Don't worry as much about what they mean. So it has to have this set of modifiers, public static void, but then the name of the function, which is new line, and then the parentheses, which denote the arguments that it might have. And so I'm going to create no arguments here, but I'm going to do something inside of here. So I'm just going to do system.out.println. So println with no arguments, what does that do? Just print a new line. Yeah, it prints nothing. So so remember, I talked a little bit about the difference. I didn't really talk about it. I showed it one time, I think, the difference between print and println. Print doesn't go to a new line. Println does. And so if it prints nothing and then just goes to a new line, it's the same as sort of inserting a new line. And so I can insert that in my main program and call it the same way that I would call any other function. I put the actual name of the function and then the arguments. So in this case, there are parentheses, of which there are no arguments. The main difference between a variable, well, not the main difference, but the main syntactic difference between a variable and a function are the parentheses. You can tell when functions are being called, because even if there are no arguments, you still have the parentheses, whereas variables don't ever have parentheses. So I can, let's do something just to show that this is in fact working. So I'll print and then underneath it, try something else. And so if I go ahead and compile this, I left my semicolon again, and I have LNT. Thank you. And I have, so I messed up my T because I was typing so quickly because I'm just so excited. So when I type this, I get, you get away from me, and then a space, and then no, you get away from me. So what's happening here is that it's going and running the statement. It sees this function here, which brings it down and evaluates whatever is in this block. Then when it's done, it returns back to where it was, and then continues executing the code. I can add another function, so I'll use my same group of modifiers, and let's call this 3 lines. So now, what I can do is I can encode basic statements in here, but I can also call other functions that have already been created, just like I would in my main block. So I can call maybe new line 3 times, and so maybe I have some functionality in my program where I want to be using 3 lines over and over and over again. Rather than typing new line every single time, I can sort of condense it all into a single function and then just call that. So instead of calling new line, I'm going to call 3 lines. Compile it, run it, and now I get an even bigger space. And so you can sort of condense sort of your ideas and your program flow in additional functions. And so we'll start to see on Friday, we'll create sort of more and more advanced functions, and you'll see this is a good way to do what we call encapsulation. So if you want, say, someone using your program, so you want to give them things to do, you can sort of hide the implementational details. For instance, when I'm using math.sign or math.power, POW, I don't know what it's actually doing. I just know I can call it, and it will do something. And so throughout this course, you'll be writing functions that people might be able to call and use to do something, but the actual details of what's going on in that function might be hidden from them. It might be in a file. It might be somewhere else. So we'll end on that today. Good luck finishing up your Scratch projects tonight, and we'll continue with functions on Friday. Hey.
As I was finishing my project last night, I found a question.
Okay.
And it's hopefully not incriminating. I can't find any way once you, like, there's a way to stop scripts,
yeah.
But there's, like, no way to start them again.
You start them automatically? Okay, so...
Yeah.
There's sort of a way to get around this. So have you used clones at all in your program? So if you Google sort of a tutorial on how to use clones in Scratch, a clone is sort of an instance of an object. So you can create, so you have your sprites, you can create sort of clones of other sprites, so it sort of duplicates that sprite and does some other additional functionality. If you stored, say, your whole program, as a clone instance, you can sort of generate new instances of your program, and then so every time, so you can create and delete clones. So you might say at the end of your program, create a new clone, which is sort of a new program, and delete this one I currently have. It will sort of automatically run and start again. So, I mean, yeah, I don't have time to go over the entire functionality of clones, but yeah, look it up.
Cool,
So
thank you
that's
so much.
one idea.
Great.
Hey guys.
For the worksheet that you posted, is it like you post once a week or?
I'm going to try to post about one per week, yeah. So my goal is to post one sort of for every discussion. But if we start getting into where the projects are becoming really intense or I'm running out of time, maybe I won't. I'll miss a week here and there. But yeah, I'll try to keep it up.
It really helped. Like,
Good. That's
and then today I wasn't as lost as I was before. So
that's what I want to hear, because I spent probably more time on that than I should have. And so I'm glad to hear that it helps. Good.
Thank you. Question about the doubles. Does that also consider as floating point?
Yes, so a double is a floating point number. It's just more precise. It's called double because it's